in treatment and control of ammonia at point of use, which is very important, product quality, flow control. We will say a few words about legislation for ammonia storage and atmospheric control in the furnace. So, nitrogen is a thermochemical treatment process with nitrogen enrichment of surface for hardened steel. And the goal is to achieve high surface hardness, more than 1,000 vickers. And it is done at temperature between 480 and 600 degrees. This low temperature has some good advantage to limit deformation of the pieces and no phase transformation. So it's a low temperature processes, and it has a main advantage for that. So gas nitriding, you need to have a nitriding medium is a mixture of nitrogen and ammonia gas. And only the ammonia will dissociate is the first reaction, and only the non-dissociated ammonia, which goes on the surface and will crack on the surface with catalytic reaction of the metal, and will crack and make a nitrogen enrichment of the surface. So you have two processes to integrate atoms in the metallic structure. So first stage is enrichment of the surface with so-called white layer. It's up to 20 to 30 micron. It is to give make of iron nitride. It's to give a very high resistance to friction. And the second stage is so-called diffusion zone. It is much, the depth is up to 0.5 millimeters with nitrogen with combined with alloy equipment, alloy elements. Depending on the time, nitrogen time, for short nitrogen time, much more a white layer, and if you want to make more diffusion zone, you need high nitrogen time, up to more than 8 hours. So the control of the nitrogen potential is very important. So you have the formula at the bottom of the slides, and it depends on the degrees of dissociation of ammonia. It depends on the flow rate, of course, and temperature. So nitrogen treatment are efficient when you are reproducible, safe, and then you can be cost efficient. And you need to control the whole production chain. So not only on the furnace, nitrogen furnace, but before preparation of the parts, but also quality of ammonia and the recipients, and after. So if you want to have a reproducible process, you need to control and master, not only have a look at the equipment and the furnace, but also before and after. So we'll start to speak about point of use and what's happened before. So the two especially, it's very important to control the ammonia flow rate. Measurement at the furnace is very important, and of course quality of ammonia at point of use. And the quality of ammonia at point of use, you need to control from the sourcing of the product up to the point of use, with the filling of the recipient and the transport and the quality and the cleanness of the recipients. So about ammonia, so ammonia is a chemical product which strong and unpleasant smell. It is colorless gases. It's a little bit flammable, but main feature is a toxic gas. So it must be avoid all contact with body, human body, especially skin, eyes, and so breathing. So it is stored in recipient in liquid form. It's only compressed in order to be liquid. The recipient are not isolated, and the liquid ammonia is in equilibrium with this vapor phase in the recipient. So the pressure varies with the temperature, as you can see here in the red curves. So the supply, quality control of the supply. So the sourcing of ammonia comes usually for chemical plants, and the supply of raw products comes to the filling plants with a certificate of conformity. So each drop comes with 30-ton wagons and with a certificate conformity, and we control the purity of the ammonia for each delivery coming from the sourcing from the chemical plant. And quality control is done at each step of the transfer from the tank to each recipient. So about quality of ammonia for gaseous nitrating. So this is the specification for so-called alnite 8 from ammonia from Air Liquide. And main impurity is water and oil. So less than 50 ppm water and 1 ppm oil. So these are important specifications for ammonia processes, for gas nitrating processes, sorry. And why it is important to control and to have consistent impurities, mainly it's to avoid accumulation of impurities in distribution system at the flow control system, at the point at customer before on the furnace, and especially oils. If you have accumulation of oils, it is very perturbating for the flow meters, and especially mass flow meters. So mass flow meters are very sensitive to this oil, which accumulates with the time, and then you have a drift of the measurement of flow rate. And if you have a drift of measurement, then you have no control at all of the gaseous nitrating. So it is a key point to use pure ammonia for gaseous nitrating. And if you have to clean nitrating ammonia pipes, it's very difficult, because you have to purge, you have to stop. It takes a lot of time, it makes a lot of disturbance on the production. So about the packaging, so ammonia is filled in recipients. There are different kinds of recipients, 44 kilos, or there are some containers, 250 kilos or 500 kilos. And it's important that not only the ammonia is pure, but the recipient has to be clean. So if you put high purity ammonia in a dirty recipient, then it's nothing. It's not used, make no sense. And ammonia is also used not only for heat treatment, but you can have also recipients going to cold system for cooling system or industrial, and then you can have recipient coming back to the filling station which are dirty. So for ANAT 8 we have dedicated recipient only for heat treatment. It's very important to have dedicated recipients only for heat treatment customers, to avoid contamination on the recipients coming from other industry, especially for cooling ammonia, for cooling systems. about filling. So each control of batch is validated with a measurement and purity before distribution. And now we come to the equipment for flow control for nitriding, for the use of ammonia for gaseous nitriding. So you see here an example of those kind of equipment for the distribution at a customer site. So it is essential to properly design those systems. First of all, about safety. Ammonia is a toxic product, but also for stability of the treatment, to have constant pressure, constant flow rate, and to have the maximum use of ammonia, which is stored in the recipient, and to have reliable operations, and not at least also to comply with legislation standard. About how to take out ammonia about the recipients, so there are two different kind of to do it. First of all is extraction in gas phase. So in this case, the vapor of ammonia is taken out of the recipient. As we take the vaporizing in the bottles, then the temperature drops, temperature drops. And the pressure decrease as the temperature drop and the pressure decrease. And this can lead to, first of all, freezing of the bottles, and also about the high pressure reduction, which means a limitation of the flow rate. So those systems to extract in the gas phase is limited for low flow rate, so only for limited flow rate. For higher flow rates, you need to extract in the liquid phase with submerged pipes. And in this case, we take out the liquid outside of the recipient and we vaporize it externally with electrical heated heaters, vaporizer. In this case, we can take out much higher flow rates with the extraction of liquid phase. So both systems are possible. And of course, you have to design the system to select the right way to extract ammonia and the distribution system depending on the needs. And the needs is done for the ammonia consumption. So you see here for gaseous extraction, you can use only a limited flow rate, 0.5 kilo per hour for 44 kilo cylinders, maximum 5 kilo per hour for 500 kilo containers. And if you need higher flow rates, then you need to have extraction in liquid phase. And equipment manufacturers, furnace manufacturer gives a recommendation about the maximum flow rates for the gaseous nitriding, and we have to take care about this specification and design properly the distribution system and to select the right ammonia storage capacity. So if you have an improper installation, then you have a risk to flow rates, deviation, pressure drops, malfunctioning, and you have a bad control of the gaseous nitriding process in the furnace. So we make a checklist for each project, depending of the flow rate and mode of extraction, depending on the selection of the type and number of containers, security requirements, installation type, definition of pressure reducer type. So use these with checklists for each project. So here you have nice example of some installation. You see here systems for distribution of ammoniac. You see here some cylinders, and in yellow this is the electrical heating evaporating system for one you can have 15 kilo per hour or up to 30 kilo per hour for one system. So depending on the flow rate, we use 1 or 2. We have also automatic inversion systems to have permanent delivery when you change cylinders, not to interrupt the process. So we have automatic switching from one serial of cylinders to another serial of cylinders. So usually we work with two cylinders, or three, or four. And when one serial is empty, it switches automatically to the full, and we can change empty against a full recipients without interrupting the production, of course. And then you need here for control of regulation. So this is an example for liquid extraction here. So state of the art is to make the system in a container, sea container, to manufacture in workshop and to delivery, which is ready to use for at a site. Only to make connections with flange connections and electricity, which save a lot of time. So this system now it's standards for liquid extraction. So all the container is heated and with extraction and safety monitoring. So we use there is a need also for electrical control. So we have one example here for electrical control cabinet, which is usually outside the container. So also very important work for ammonia distribution system is documentation and training, for instruction, for operating, training on site, and documentation in order to properly use the system, and also to have the safety data sheets and maintenance and troubleshooting. So this is part also of the equipment. Let's go with one word about legislation. So what's important to know, it's a regulation concerning ammonia storage in Europe. It's only national. There is no European regulation. So each European country has its own legislation. So here you have example from Spain. So there are different regulation and instruction and directive which it's necessary to take into account. And these directives, depending on the total capacity of ammonia which is stored on one site, and for each cylinder, the size from each cylinder. So you have example from Spain here. For France, you have different directive, and so if you have question about legislation, we can discuss it with our Spanish colleagues. So, for example, France, the selection between cylinders or containers. You have cylinders on the top and containers, typical containers. These are 500 kilos containers, and these are 44 kilos for cylinders. Depending of units for less than 1.5 ton ammonia stored at one location. If you are below this level, you need a simple declaration, and if you have above, you need authorization, which is much more difficult and complex to obtain. And also, if you have more than 50 kilo on one recipient, you need this authorization. So sometimes it's better to use cylinders to avoid the declaration, and, but of course you need more delivery because we have smaller capacity, 44 kilos, and just for high flow rates, then of course cylinders is the good solution. So about reproducibility of nitrogen treatment, so we can speak now about the furnace, the equipment process. We'll speak about upstream. We can speak now about the furnace itself. So you have many factors which can influence the processes. And on the furnaces, so for example, the muffle, metallic muffle, if it oxidizes or not. If it's oxidized, the hydrogen will react with the oxide and make iron. And this iron will have influence on the dissociation rate of ammonia. So it's very important that the muffle is ready to use for nitrogen. Also the load, the surface of the load is very important to see how big is the surface. Also the cleanness of the parts before treatment to avoid grease and oil under the surface preparation. All these are very important influencing factors. Inside the furnace, the design of the furnace, so this is done by the furnace manufacturer. So we can list three main parameters: homogeneity, furnace temperature, atmosphere recirculation, so turbines with high recirculation in the furnace. It's a state of the art, and analysis devices to control the nitrogen ratio. This analysis device has to be calibrated and maintained regularly in order to have the right measurement of the dissociation factor. If these factors are not under control and not stable, you will have uncontrolled treatment, and flow rate will not be optimized, and then it's a loss of productivity, of time, defect parts, and it can create very quickly trouble at the production line. So for troubleshooting, so all these points has to be taken into account. So atmosphere is very important, but there are also other influencing factors. So when we check the atmosphere, we need also to have a look at all these other parameters to see where that's going to the root cause from the trouble. So conclusion. So ammonia flow and quality control at furnace is, and at point of use, is very important to have good process control of the nitrogen processes. So for that, quality of the supply, quality of the product, from the complete supply chain from sourcing up to point of use. Second point, to design correctly the distribution system at point of use in order to extract correctly ammonia from the recipient, and avoid maintenance by selecting equipment with time. To design correctly can be with a bypass or redundant, in order to have a reliable system and safe system. Benefits for good control for heat treatment, so of course to have a stable production, to have a high productivity, to use the equipment at the full operating time, avoid maintenance, avoid defect, optimize gas usage and gas cost, and safety operation and production for the whole equipment. So this is mandatory to have all these factors in mind, and in order to optimize the gas nitrogen processes. So these are the main factors. If you have some questions, I can answer in Spanish. can say in Spanish, no problem, about ammonia. Use ammonia.
Em resumen, más o menos en español, si queremos, en resumen, si queremos tener una nitración bien hecha, y no solo una vez, pero siempre, hay que elegir un amoníaco de calidad adecuada. Y la calidad es muy importante, no solo la calidad en general, pero sobre todo el contenido en impurezas que hay que controlar. Coger un amoníaco de calidad industrial significa muchas veces coger aceite y humedad que viene de otras aplicaciones normalmente de frío industrial y que desafortunadamente cuando aplicadas en tratamientos térmicos, sobre todo en hornos que tengan calorímetros básicos, normalmente resulta en daño en los calorímetros, retrasos, mala nitrulación, muchos retrasos que de alguna forma obligan a un mantenimiento curativo de emergencia para reponer las condiciones de nitrulación en los hornos. Normalmente todo esto obliga también a una instalación adecuada y si la instalación es bien hecha, está bien proyectada, conseguimos mantener la calidad que viene en el recipiente en el punto de utilización del horno. O sea que de una cadena de producción completa y no solamente de la botella o de la calidad, pero si respetamos toda la cadena, tenemos no solo una vez, pero siempre una nitrulación exitosa, bien hecha y reproductible. Es eso que nosotros podemos ofrecer y bien, si algún día necesitáis de alguna información más, estamos disponibles.
Okay.
Gracias.
Gracias, muchas gracias.